So we can use either one of these formulas and we should wind up getting the exact same slope. They're both representations of slope. So I can either use my formula 1, the slope is equal to the limit as x approaches a of f of x minus f of a divided by x minus a. Or I can use my new formula that we just learned. My slope is the limit as h approaches 0, or the change in x approaches 0, of f of a plus h minus f of a over h. Now, we're doing this using the parabola x squared, and we're using the point 1, 1, which means that the x squared is our f of x, and the 1, 1 is our point of tangency. This means that a is equal to 1, and f of a, or f of 1, is also equal to 1. Let's use our first formula. In the first formula, we would say that the slope is equal to the limit as x approaches my a value of 1, where f of x, which we know is x squared, minus f of a, which we know is 1, is being divided by x minus a, or x minus 1. We're going to simplify it. My slope is the limit as x approaches 1 of, we factor the numerator, difference of squares is going to give me x plus 1, x minus 1. This is all over x minus 1. We remove the common factor from the numerator and denominator of x minus 1, which means that we have the limit as x approaches 1 of x plus 1, and I can do direct substitution. My slope is going to be 1 plus 1, or 2. Using the second formula, my slope is equal to the limit as h approaches 0. The nice thing about this is h always approaches 0 because we want the change in x to get closer and closer to having no change in x. Of f of a plus h, we'd write as a plus h squared, except for we know our a value is 1. My f of a, we already know, is still 1, and this is all being divided by h. Now I can factor this using difference of squares, and I'm going to say my slope is equal to the limit as h approaches 0 of 1 plus h plus 1 and 1 plus h minus 1 over h. When I simplify the first one, I wind up with h plus 2. When I simplify the second one, I wind up with just h. And then I can factor this h out of the numerator and denominator. This should be a common trait whenever you're using this formula. At some point, because h is approaching 0, which is non-permissible, we should, if we can do this properly, be able to remove the common factor of h out of the numerator and denominator so that we can actually substitute or use direct substitution to say that the slope is equal to, if it is h plus 2, then it's going to be 0 plus 2, and actually solve that I get 2. And we can see that in both cases, the slope is equal to 2. If it says determine the equation of the tangent line to the rational function xy is equal to 1 at the point of -2 and -1/2. We're going to take the information that we have and we're going to state that y is equal to 1 over x, which remember is our f of x. From the point of tangency, we know that a is equal to -2, and f of a, or f of -2, is equal to -1/2. Those are the three pieces that we need. And at this point, I'm going to pick one of my formulas to use. Doesn't really matter which formula I pick. And I'm going to say, let's use the h formula. The slope as the limit h approaches 0 of f of a plus h minus f of a divided by h. I'm going to substitute the values in. The limit as h approaches 0. If I have f of a, then that's going to be (1 over -2 plus h minus my f of a is -1/2. And this is all being divided by h. Now, because I have rationals in the numerator, I'm probably going to rewrite this in a simpler way. I'm going to say that the slope is equal to the limit as h approaches 0 of 1 over -2 plus h. I'm probably going to change to h minus 2. Just change the order of the sum. And if I have the negative of -1/2, I'm going to say it's +1/2. And this is all being divided by h. Now remember, in order to combine these two, we need to put them over a common denominator. And lowest common denominator is 2 and a plus h. So I need to multiply the first one by 2. In both the numerator and denominator. I need to multiply the second one by that h minus 2 in both the numerator and denominator. And that's all over 2 and h minus 2. Divide by h is the same as multiply by 1 over h. This is going to give me the slope is the limit as h approaches 0 of 2 plus h minus 2 is just h over 2 and h minus 2. And when I multiply this by 1 over h, I just wind up with another h in the denominator. And the h in numerator and denominator cancel out like they should. And then I just wind up with the slope is equal to, because now I can do direct substitution, 1 over 2 bracket 0 minus 2, which is the same as -1 over 4. And there's my slope. Because it wants the equation in general form, the second part is I'm going to do the equation. So using y minus y1 is equal to m bracket x minus x1. I'm going to use my point of tangency, y minus -1/2. Use my slope that I just solved, -1/4 bracket x minus -2, which means I actually have y plus 1/2 is equal to -1/4 x plus 2, or y plus 1/2 is equal to -1/4 x minus 2/4, or 1/2, whichever way you want to do it. And I'm going to multiply every single term by 2 because I want it in general form, so I need to get rid of those fractions. Sorry, not by 4, 2 by 4. So I wind up with 4y plus 2 is equal to -x minus 2. Then I'm going to move this to the left-hand side because that x is negative. And I wind up with x plus 4y plus 4 is equal to 0. And there's my final answer.